Hey everyone, all right, so notes 4, we're going to apply properties of exponents, radicals, rational exponents, and steps for solving equations. The grammar is super awesome. So we're going to talk about linear, quadratic, radical, and fractional or rational equations. This lesson is going to focus mainly on linear. So linear equations, if you remember, you would have slope-intercept form, okay, where m was your slope. This B was your y-intercept. Okay, and that's what you would use to graph your line. And then to find your slope, if you were given two coordinates, you would take the difference of your y's over the difference of your x's, and you would get something for your slope. The other thing that you talked about with linear equations was standard form. And standard form is ax plus by equals c. A is always a positive number, and A, B, and C are always integers, so they cannot be decimals, cannot be fractions. And then you also had point slope form. So point slope is not talked about very much in here, but for AP Calc, you do need to know it. So you have some y minus your coordinate y that you know. Then you have it equal to your slope times some x and then the coordinate for your x. So if you're given a point and you're given slope, hence point slope form. Okay, so you need some xy1 and your slope to be able to do that. We talked about parallel lines, so that's the symbol for parallel lines. We've talked about perpendicular lines. So for parallel lines, if you remember, they have the same slope. And for perpendicular was always the opposite reciprocal slope. Okay, so these are the main things that you need to refresh yourself on for linear equations. So we're gonna roll down here to quadratic. We will do these in note 6. So quadratics you see a lot in this form, y equals ax squared plus bx plus c. And then to solve them, you need to see where y is 0, so you can find your roots or solutions. So you would set it equal to 0 and then solve. So you can do this with factoring methods, which we'll talk about. So the normal way to factor trinomials, oops, don't want to do that. You can do difference of squares, things like that. You can also solve using square roots, which we'll talk about. And then there's the, always legendary quadratic formula. So your quadratic formula is unless you're told otherwise, unless you're told to use it, it's kind of a last resort solving method. So you would take your x equals opposite b plus or minus b squared minus 4ac all over 2a. So make sure that b squared minus 4ac is under the square root. And then if you recall, and we probably won't do a lot with this year, but that b squared minus 4ac, that is called your discriminant. It just helps you determine how many solutions you're going to have. So, all right, now moving to radicals. So radicals we'll do in note 7. So you need to make sure, sorry, let's make train of thought. You need to make sure that you get the radical by itself all alone before solving. So we'll talk about that, what that means. So if you have something, for example, that looks like this, when you solve radical equations, you will square both sides if the radical is by itself. So then you're left with possible answer and a possible answer of x. you're going to check for extraneous solutions. We won't do that until later in the year. I just want to make sure that you know how to solve the actual equations first, and then when we get there, we'll talk about extraneous solutions. So then moving on to fractional rational. So for fractional rational, again, we will hit later in this year. We won't do it in this unit. So fractional rational, they, for example, look something like this. Rational equations because they have fractions in them. The main thing you need to look for is your common denominators. Okay, that's the main thing you got to look for. And then you'll also check for extraneous solutions. Okay, extraneous solutions meaning if you get a number, you need to make sure that it works for the problem. And again, we'll cross that bridge when we need to get there. So some examples I want to run through so this video won't get crazy long. Solving linear equations or just solving for an unknown, that's what 1 and 2 are talking about. So if you can solve for x or solve for y, this is just solving. These are both linear, except one of them has a y in it. So I'll have you do these on your own. The main thing for number 2 is I want you to try to solve, but you need to get rid of the fractions first. Okay, I want you to try that strategy. So if hopefully you understand what that means. If you don't, again, that's something you should write down. You should ask me, hey, what did you mean by that? I want you to go ahead and do those on your own. All right, so for 1 and 2, those are the answers that I got. So if you need to pause the video to check your work, go for it. You should get x equals -3/4 for number 1 and y equals 21/11 for number 2. So I want to take a look at number 3. It says put in slope-intercept form. So the same strategy I wanted you to try for number 2. We're going to get rid of the fractions first. So we're going to walk through that part together, and then you're going to finish the problem on your own. So you can see that there is a lot happening in this problem. Okay, there's a lot of fractions, a lot of things going on. So I want to look for the lowest common multiple for this problem. So lowest common multiple to get rid of the fraction. So I see I have a 10, I have a 4. I'm thinking my lowest common multiple is 20. So I'm going to multiply everything on both sides by 20. So I can just go ahead and get rid of the fractions. So if you're someone who doesn't like fractions, this is for you. So when you do that, you have to make sure you distribute to everything. So like for this first fraction, you have 20 times this x plus 2 times x minus 5 all over 10. You're going to reduce because you can cancel the 20 with the 10. You're left with 2. So you would have 2 times x plus 2 times x minus 5. That would be what's left. You wouldn't have anything in the bottom. And then you would have a minus 40 when you do the 20, this one, the 20 times the minus 2y. So same thing on this side. So if you do 3/4 times 20, you get the 15y. And then you'll have a 20 in front of here, so minus 20 times 4 minus 3y plus, and then another 20x here. So it does make your numbers a little bigger from time to time, but it does get rid of all of those fractions. So at this point, I want you to finish out the problem and put it in your slope-intercept form. Your slope-intercept form is on the first page of these notes. All right, so for number 3, it was kind of long and challenging. So I got y equals negative 14 over 115x plus 12 over 23. So if we get different answers, please just say something. We can talk about it. There's a lot going on there. So if you're not sure how that happened, or if I'm wrong, just please let me know. So for 4, write a linear equation slope-intercept form that passes through the point and has a slope of 1/4. So I actually, there's 2 ways to do this, and we're going to do them both ways. So you can use point slope form, because you have a point and you have a slope. And then we're going to do another way that you can solve this. So point slope form, you just need a point and you need a slope. Our slope is 1/4 and we have our point. So I'm going to take y minus my y1, which is -1, equal to my 1/4 for my slope, my x minus my x1, which is 2. So this changes to y plus 1, 1/4 x minus 1/2. I'm going to subtract this 1 over, so y should equal 1/4 x minus 3/2. Okay, so the other way you can do this is you can take your slope-intercept form that you have, and you can plug in your y value, plug in your slope, plug in your x, and then all you're trying to look for is that y-intercept, and you get the same answer. So this is 1/4 or 1/2, I'm sorry, 1/2, and adding b, subtract the 1/2 over. So now b equals -3/2. So then the extra step is just being able to write it as the equation that it was given, or the equation that it wants. So same answer, two different ways. You just need to be able to use point slope form because you do need to do that for tangent lines in AP Calc. Okay. So for number 5, write a linear equation in slope-intercept form that has an x-intercept of -3 and passes through the point of intersection of those two equations. So there's a lot happening here. So for this, first thing, we need to find this point of intersection. That's the first thing. Okay. The second thing is we need to take a look at our x-intercept and what that is. Okay, that's the second thing. And we'll use that information to write our slope-intercept form. So if you remember from Algebra 1 days, if you have two equations, you can find the intersection. We're going to do this algebraically. We're not going to do it in the graph. So I'm going to take my information and I'm going to put both of these equations in slope-intercept form. Okay, so that's what you need to go ahead and do now. Put the blue equations in slope-intercept form. All right, so these are the equations I got. So you're probably asking yourself, well, why are we doing that? Because, you know, we could do so many other things. So instead of doing elimination and doing this whole big long process for elimination, I want to use substitution. Okay, so if you were going to graph this, you'd have to put them in slope-intercept form anyway. But I'm going to use substitution because if y equals this equation and y also equals this equation, that means that they have to be equal to each other. So that's exactly what I'm going to do. I'm going to set these equal to each other and solve. I'm going to substitute because y equals one thing and y equals another, so I have to be able to get whatever x value is in there. So I'm going to use the strategy that we talked about, using my lowest common multiple here to multiply both sides, which is 20, to get rid of my fractions and solve. So this ends up being -12x plus 8 equals 5x minus 60. Okay, so we're going to solve for x here. So you can, move around how you need to. So go ahead and solve for x. All right, so I got x equals 4, and then when you get x equals 4, you're going to plug that back in so you can get your y value. So I have y equals 1/4 times 4 minus 3 here. That's 1 minus 3, so -2. Okay, that's -2. So you're probably thinking that we're done. We're actually not, because we still have to write an equation for a line that passes through the this point of intersection and has an x-intercept of -3. So I'm going to use my x-intercept and this point, because this point is 4, -2. Okay, 4, -2. and my x-intercept ends up being -3, 0. Remember, root solutions, x-intercepts, that's where y is 0. So I'm going to use my formula for finding slope to find the slope of this line. So I have my y's on top, I've got my x's in bottom. Okay, so now I have 2 over -7. So then I'm going to use point slope form. So y minus, it has to pass through either of these points, the x-intercept or the intersection. So I'm going to go ahead and use the intercept because that makes my life a little easier. So 2 over a -2 over 7, and then x minus a -3. So y minus 0 is 0. -2/7 x. All right, x minus 6 over 7, because this changes to a plus and then you multiply, so then you get -6 over 7. Okay, so that would be the answer that we're looking for. And again, if something's not right, it's not coming out right, you're not figuring it out, please let me know. Or if I did something wrong, again, please let me know. All right. So let's take a look at number 6. Write a linear function f such that f of -8 equals 3 and is parallel and perpendicular. So you have the same equation for part A and part B. The important thing to know is that when you have this notation that I'm zooming in on right here, this is your input of x, and this is your output of y. So this is actually a coordinate that they're giving you. Okay, that is a coordinate. So remember x input, y output. So if it's in this notation, function notation, that's what that looks like. They're putting in x and they get the y out of it. They're putting -8 in, they're getting 3 out of it. So if you remember parallel, you have same slope, and then perpendicular is your opposite reciprocal that we talked about. So you need to find your slopes for both A and B. Find your new y-intercept for this function. So if you do it that one way that I showed you, you're going to find your y-intercepts and then rewrite it in slope-intercept form. Or once you find your slope, you could do point slope form. This is a great opportunity to do point slope form for both of these to get your new equation. So I want you to go ahead and do that now. All right, so these are the 2 answers I got. So if you did part A, it made finding part B a whole lot easier, because if you look, your parallel slope is -2/3 once you solve for the equation that you're given. So then you could use point slope form, which we're going to be practicing, to get your new equation. So if your parallel slope and your original slope are -2/3, that means your perpendicular slope is opposite reciprocal, so 3 over 2. So then again, do point slope form, and you end up with y equals 3/2 x plus 15. So that is linear equations. That's the kind of stuff we're going to be working on, and that's why I wanted to review it. So if you have any questions, please ask. Have a great day.